I'm very happy to be able to introduce the BAM Data Store here today, especially since this will likely be my last talk on the data store because, as Sonja has mentioned, I'm changing to the Robert Koch Institute in the future. But I think they're also using OpenBIS, so maybe I will in some capacity still be involved with this topic. But anyway, the topic today is about BAM. And I think some of you might have already heard of the Bundesanstalt für Materialforschung und Prüfung, but I will give a very short overview anyway before jumping into the topic of research data management and how it is handled at BAM. So BAM is a senior scientific and technical federal institute. We are under the Federal Ministry for Economic Affairs and Climate Action, BMWK in German. And basically the task of BAM is to do research, tests, and also advising to protect people, the environment, and material goods. BAM is subdivided in 11 different departments, which are again subdivided in over 70 divisions or sections. And in total, we have over 1,600 employees. So we're kind of in the middle range of a scientific institute. And we're also a little bit spread out over Berlin and Brandenburg. There's several different locations. The headquarters is in the south of Berlin, unter den Eichen, but we also have branches in Adlershof and technical test site in Horstwalde. And since this probably doesn't sound complicated enough yet, the research activities of BAM are also quite broad. They're organized in 5 interdepartmental focus areas called energy, infrastructure, environment, materials, and chemistry and process engineering. And this diversity in research topics kind of already represents one of the big challenges that we face in terms of introducing a standardized RDM framework for the whole institute, because everyone is doing really different things, from nanomaterials to testing of the structural integrity of really big infrastructures. So we have completely different scales, completely different materials that we're researching. Currently, or at the moment, I might say in the past, but this is kind of still the situation today at BAM. There is no central RDM system before the BAM data store, which basically meant that all the data was distributed on the central file shares. There were some individual research data management solutions for research groups, for example, some domain-specific databases. But there was also data isolated in so-called data silos, some PhD students' hard drive. And one big problem was also that experimental setups are still to this day often described in paper notebooks, are rarely digitized. And this leads to having this kind of gap in the research trajectory, because the raw data isn't really connected to the processed data, and the metadata describing it is often missing completely. So we're kind of missing these interconnections between the different data points. So what we are now doing with the BAM data store, we are planning to, for one, save all of this data in one central platform. And second, we also want to describe all these data with more or less standardized metadata. So our vision is that all new research data generated at BAM will be stored in the data store, also archived there for the long term in accordance with good scientific practice. And we also want to describe all data by metadata to make it fair, make it traceable and comprehensible. And ultimately, of course, also reusable. For this, we are using OpenBIS as the underlying software. So some of you might have already heard of OpenBIS. It's an open source software originally from the ETH in Zurich, where it's still actively developed by the Scientific IT Services since, I believe, 2007. It originally comes from the life science domain. So OpenBIS stands for Open Biology Information System. And originally it was only like a research data management framework, but nowadays it also includes an electronic lab notebook or ELN. And OpenBIS can be accessed both via a browser-based graphical user interface or GUI. And there are also several APIs, for example, a Java API and a Python API to access it programmatically. OpenBIS is subdivided, I would say, in 3 main compartments. There is the inventory management system, which is meant to keep track of all the, basically physical, but maybe also immaterial stuff that you have in the lab. So all the materials, the instruments, but maybe also your methods or a database of your customers. Then there is the lab notebook compartment, which is basically the ELN, where you're supposed to describe experiments in a more or less standardized manner. And of course, at the core of this is the data management, which enables the users to store data connected to both experiments or inventory items. OpenBIS has a range of functionalities. I think most of them are nowadays pretty standard functionalities, which many research data management and ELN software systems share. So we have an access rights system. We can have different groups in OpenBIS, which have different access rights, as well as different access rights for users. There is an audit trail for all the metadata, so everything that gets changed or edited will be found in the database later on. There are different ways to import and export the data. There's also something called a big data link if you just want to link data that isn't actually stored physically in the data store, but this is functionality that we at BAM haven't tested yet. There's also a storage management system, a barcode functionality about which I will talk a little bit later. And you can also integrate your data analysis, for example, via Jupyter notebooks. And since OpenBIS is an open source software, you also have the possibility to kind of develop your own plugins if you want to. In terms of the data structure, OpenBIS is very flexible, we think, which is also one of the reasons why we have chosen it for BAM, because research at BAM is so heterogeneous that we can't really have just one standardized metadata schema. So people need to be able to develop their own. And the basic principle of OpenBIS is this kind of hierarchical system of folders and entities. So at the top level, you have a space folder, which basically just has a code, a name, and a description. And at this level, you can access the access rights. And then you have another folder level, which is called project, which is basically the same, just one level below. And then you have so-called collections, which are folders, which can also have user-defined properties. And you can have many different collection types. And then at the core, you have the objects, which are entities, again, with user-defined properties, and there can be many different object types. An object type could, for example, be a chemical, a person, an instrument, a specific experimental step. So anything you want to represent, you can represent as an object. And in terms of the data, you would put that again in a folder, which is called a data set. A data set can also have user-defined properties, and there can also be many different data set types. So this probably sounds very abstract, and this is why we'll go into a little bit more detail soon. But first of all, I would like to talk a little bit about the different ways to represent metadata in OpenBIS, which are the properties. So you have the, I think, usual data types, which you can represent as properties from Boolean, integer, real, free text, longer free text. Very importantly, also controlled vocabularies. And then we have a few things like dates, timestamp, and hyperlinks. Importantly, at the moment, only single value properties are possible. But we have heard from the ETH that they plan to introduce multi-value properties for the next big OpenBIS version, which will probably come later this year. So that you can, for example, not only choose a single value from a controlled vocabulary, but several at the same time. When users interact with OpenBIS, they kind of have two different dimensions that they have to think in. So the first dimension is kind of the type definitions, which are done by admins. So I've already mentioned this. We have collection types, object types, and dataset types. And then these can have different properties. And then you also have to define the controlled vocabularies. And here, just as an as an example, an object type called instrument, which would have, for example, the property name, the property room, and the room number would then be a term which is part of a controlled vocabulary. And then maybe we have another property which is called calibration, and that would represent the calibration date. And all of this is not predefined in OpenBIS. There are a few object types already predefined, but the majority of them has to be defined by admin users. And on the user side, they will then have the possibility to, first of all, follow this folder hierarchy to represent their research processes. So they have their own space, and then they can make different projects inside. And this could, for example, then look like this. We have an equipment space, then we have equipment for group 5. Group 5 has lab instruments in a collection, and one of these lab instruments would be the instrument super device with these properties. And then we could attach a data set here, for example, user manual as a PDF. For the data sets, OpenBIS is completely agnostic in terms of formats, so you can save any kind of data format. You can save single files, several files, maybe also folders with subfolders inside of them. So you have many different ways to put your data in there. And then there's also the possibility to create links between the different objects, and these are called parent-child relationships in OpenBIS. And the result of this will be, for those of you who have ever learned graph theory, this would be a directed acyclic graph. So we can't make circles, but we can kind of follow the research trajectory. So for example, we have done an experimental step, which is called measurement 1. And measurement 1 used super device X as the instrument. And then we had another experimental step called measurement 2. And in the end, we have an analysis step, and we can have these kind of interconnections between them. So this is kind of a short example of how this could look like in OpenBIS, but I think instead of showing more images, I will just have a very quick switch to the actual OpenBIS demo instance from the ETH, so we can have a better look at how this looks like in practice. I hope you can still see my screen. I don't hear anything to the contrary, so I will continue. So you should now see the OpenBIS demo page.
Yeah, it works. It works.
Great. Okay, so you can find this under openbis.ch and then index PHP demo. And this is the demo for the life sciences. So this is now the user interface for OpenBIS. And you can see here already this kind of subdivision that I've been talking about, the lab notebook and the inventory. And the user could then go to the inventory and see different kind of folders and subfolders. So here we have a space called materials. We have a project called reagents, and then we have different collections, for example, for chemicals. And if we go there, we will see that there is different kinds of metadata for chemicals, for example, starting with a barcode, the supplier, some kind of number, storage position, etc. And all of this metadata could potentially be edited by the user. And if we go now to the lab notebook, you would have this by default subdivided into personal folders. So the user here would have their personal space, and then they have different folders to represent their whatever research processes or research projects. So in this case, this is an example from biology. So we have some inducible transcription factor analysis in here. And if we go here, we can find the different objects. For example, we have here the detection of some kind of transcription factor induction, and with a preview image, and then you have some very generic information on the experiment that was done here by Western blotting with free text, experimental goals, experimental results, so on and so forth. And here on the left-hand menu, you could see the data that is attached to that. So we have the preview image, and then we also have the gels in terms of the raw data. And you can see, okay, these are several TIFF images inside a data set. I think what's most interesting, however, is the so-called hierarchy graph, where you can see how this kind of objects can be connected to each other. So you remember these directed acyclic graphs that I've been talking about before. So here we see our Western blotting experimental step. And yeah, if you zoom out now, you can see, I think I need to change this a little bit so we can see more. If you zoom in here, you can see all the different steps and chemicals that are interconnected to each other to result into this experimental step. So you can really follow up what has been used to reproduce this experiment. Okay. So much for OpenBiz. Now I would like to talk a little bit about how we piloted OpenBiz at BAM, because first of all, we of course wanted to see whether it's actually usable and also customizable for BAM, because originally it does come from the life sciences. So we conducted a pilot project, which started in late 2020, early 21. And the goal was to have different research groups at BAM which applied to take part in the pilot phase, and then, do a requirements analysis for them. What do they actually need, and can they fulfill these requirements using OpenBiz? And the groups that we had here, you can see that thematically they kind of are again very broad. We had here thermal analysis of microplastics. Then we had structural health monitoring, which is like integrity of big infrastructures like bridges. Then we had a group which does nano-reference materials. And then we had also CT for non-destructive testing and additive manufacturing. So very diverse. And the way we did this in the pilot phase was to take each of these groups consecutively, start with a requirements assessment, and then do some onboarding, several webinars where they learned how to use OpenBiz. And in the end, we analyzed whether their requirements were fulfilled, whether their user stories could actually be fulfilled by OpenBiz, and if not, whether potentially there could be some more changes to do this. And then we basically wrote an evaluation report and successfully convinced the leadership at BAM that this is a good idea to roll out OpenBiz for the whole of BAM. There are also some publication about the results of the pilot project, both from us as the data store team, but also from two of the pilot groups. So you can find that here for the pilot group 2, which was working on the bridges, and then also for the nano platform. We had a number of lessons learned from the pilot projects. I will go over them quickly because I think most of them are not specific to OpenBiz, but rather generic to any kind of introduction of a research data management system or ELN. So we noticed that in the beginning, we had individual instances for each group, and this was quite a high maintenance effort and also prevented sharing of data between groups. So this was something that we only did for the pilot phase to give them a little bit more freedom. But for the real rollout, we only have one central main data store instance for the whole institute, and maybe additional custom instances if needed, but this hasn't happened yet. We gave the groups pretty much free range in terms of how they want to develop their metadata schemas in OpenBiz. So you remember all the different types and properties and so on. And this, of course, led to heterogeneity and inconsistency. There was a mix between English and German. So for the rollout, we are introducing rules and naming conventions and so on. I think this one I will leave out. One problem that we encountered was that many of the contact persons or the OpenBiz experts at BAM of the pilot groups have already left the institute because some of them were PhD students and postdocs. So for the rollout, we said, okay, we need people who are here longer, and we also need to have clear roles and responsibilities from the side of the research groups. Something that we also encountered is that researchers kind of underestimate the time that they need for the customization and the development of metadata schemas. And this is why we provide a basic set already of this so-called OpenBiz master data or metadata schemas And we also communicate very clearly that this is a task that will take several weeks, and it's not something that you can do in an afternoon. Yeah, another lesson that we had, which doesn't really require a solution because it was a positive one, was that people really liked the sample tracking via barcodes, for example, for chemicals. And they also liked the possibility to do integrated data analysis via Jupyter Notebooks. So before we started with the rollout, we did a survey across the whole institute, and we basically asked all the groups. You remember that we're about 60 to 70 groups. We asked all the group leaders what the current status is in terms of RDM and their research group, and whether they're interested in using OpenBIS. So the question whether the group uses lab notebooks was answered with yes, and definitely the majority, over 80% of the cases. But in most cases, this kind of lab notebook was still paper. There are a few generic solutions, but these were mostly like MS OneNote, and then very, very few actually had already some kind of system, but not really an electronic lab notebook yet. Then we asked them whether they're interested in using OpenBIS for research data management. As you can see, there's definitely a clear interest towards that. Some of them kind of want to use it like now, and others are a little bit more cautious. So 30% said definitely yes to the data store. Then we had around a third which said probably yes, and some were undecided. Some said probably not. So this led us to plan for our rollout. I'll go over this quickly and can answer a few more questions in the end. So the way we're planning this now is to do a phased rollout. So we're always doing onboarding phases for like 3 or 4 groups at a time over a time period of several weeks, so up to 3 to 4 months, depending on whether we have summer or Christmas holidays in between. And this way we can concentrate on the respective groups. We also try to cluster them according to the research domains. And once they have finished the onboarding, they can start using the data store, and we can continue onboarding with the next groups, and so on and so forth, until more or less everyone is able to use the data store. So in terms of the current status, we're just now wrapping up the second rollout phase. So this is a short overview of the IT infrastructure. I don't think I need to say much here because it's rather specific to how this is set up at BAM. Maybe just, very generic. We have the so-called data store server, which has on the one side the Postgres database for all the metadata, and then the file system storage, and they interact with the web proxy. And then we have different ways how clients can interact with that, mostly via the user interface, but there's also other ways to import data. And we also at BAM have something called Lab Network, which is not connected to the main BAM network, but are rather separate little networks, which you have in the labs when you have, for example, computers which belong to certain instruments and they can't be updated anymore, and have some other security requirements. So I already mentioned the words clear roles and responsibility, and I would like to say a little bit more about that. So we are a relatively small team, which has the task of introducing the data store. And of course, we can't do that alone. We need the support from the research groups. And for this, we first communicate with the division heads, so the research groups leaders, and they need to kind of appoint someone from their group as a data store steward. So like a data steward just for the data store. And these then have the task to develop these metadata schemas that I talked about before. We communicate with them, we make webinars and teach them how to do that. And they, of course, also communicate with their respective division members for feedback, etc. And in the end, the responsibility for how the data store is used and whether there are some kind of rules and recommendations for the respective research groups, that lies with the division heads. A few more words on the role of the data store steward. So as I already mentioned, this is kind of our contact person, our domain expert into the different divisions. And ideally, we're saying that these shouldn't be PhD students or postdocs. Ideally, these should be permanently employed members, just to be sure that this kind of knowledge that they accumulate does not get lost after like 1 or 2 years. They should have some domain knowledge, definitely. They should have interest in RDM, but they don't really need to be IT experts or have programming knowledge. And then their tasks and responsibilities are, of course, to take part in our onboarding meetings, to develop the division and domain-specific metadata schemas, and then they're kind of the contact person for all the RDM requirements of their respective groups. In terms of onboarding, we always call it a marathon and not a sprint, because it's really something that takes time over several weeks. So the way we are planning this now is for about 16 weeks. So we start with a kickoff meeting with the data store stewards and the group leaders. Then we have several webinars where we basically talk about data modeling, how you can develop different object types, how you can develop metadata schemas, recommendations, rules for that. And then we also teach them the OpenBIS functions in several webinars. And in the end, when basically the customization for the research group is there, we do a workshop, like a one-day workshop for the whole group, and then the normal users can start using the system as well. Maybe a few more words on the process of defining these metadata schemas. So this is also something where we have to, as the data store team, we're kind of the bottleneck in that. So the data store stewards do define their own metadata schemas in, for example, Excel format. Then they send it to us, and then we have a feedback round to make sure that all of our kind of internal rules are followed, and then we don't have duplicates with things that other groups have done before. And this is actually quite a lengthy process and does not get easier over time, because of course the entirety of metadata schemas is growing over time more and more. And we try to have as little inconsistencies in there as possible, but of course, if you give the groups freedom to represent their own research processes, you will have duplicates of things that have similar meanings over time, because we're not following any strict kind of ontology or something similar. Yeah, I already mentioned that we have some best practices naming conventions. We are also providing a basic set for metadata schemas. So for example, things like chemicals, instruments, and samples are already predefined by us. And then the data store stewards of the respective groups can make specifications for that. If they, for example, say, okay, here's something missing, I need to describe our instruments differently from that, then they kind of inherit the properties of the more generic object type and are able to create a specification out of that. We're also providing a knowledge base. So we have a data store wiki for teaching materials and documentations. This wiki is not meant to be an alternative to the OpenBIS documentation, because that already exists. What we provide is basically just the specific information that is important for users at BAM. And in case where it's just generic OpenBIS knowledge, we just link to the original documentation. Yeah, and this is kind of how we envision this whole setup of a central research data management platform to be integrated at BAM across the whole data lifecycle. So you would basically represent your lab inventory in the data store, maybe also some like project plans or tasks. You could also have as an object, and then you would collect the data via measurement devices. This could, for example, go directly to the data store or via some manual import. Then people are processing and analyzing the data, and they're using external software for that, which could potentially also communicate with the data store. Or they might be using Jupyter Notebooks and Python, and then they could use the Python module PyBIS, which OpenBIS provides. one of the main tasks of the data store is, of course, to preserve the data in the long term. We are also considering having a dedicated data archive for data that's like really long term, which is not needed in the next 5 years more than 2 times or something, but we don't have that yet. And then in terms of sharing, at the moment, OpenBiz already offers the possibility to do a direct export to Zenodo. We're also considering having our own BAM repository where data from research data from BAM can be openly shared. And then the goal is, of course, to provide fair data that can be reused. Yeah, and this brings me to the end of my talk. We have a number of plans for the future. I think I will just mention a few of them. So at the moment, our developer is implementing a so-called master data checker to detect errors and inconsistencies in the metadata files. But we will still need a manual kind of oversight over this. We also have a student working on a dashboard which would monitor usage statistics, so where we can see how much the data is growing, how active the users are, and so on. We're also working together with the Fraunhofer IWM and other Fraunhofer the Fraunhofer Verbund materials to develop a plugin which can export OpenBiz metadata as RDF triples. And we are also planning in the future to introduce barcode scanners and printers as standard IT hardware. And something very exciting that we've seen from the kind of sister institute of BAM in Switzerland, the EMPA, they're using mobile devices for OpenBiz. And yeah, at the moment, we don't have mobile devices provided by the central IT at BAM, but I think that would be very interesting for labs to be able to use that. Yeah, this brings me now to the end of my talk. I would like to acknowledge the team that's behind all of that. So first of all, Jörg Redler, who is the co-project lead from the BAM IT, and his colleagues Daniel Kostilla and Theo Friedrich, also from the BAM IT, and then 2 of my colleagues from the eScience section, Angela Risa and Carlos Malariaga, who are doing the training and development respectively. Also, big thanks goes to the ETH Zurich, and as I mentioned previously, to the EMPA. And of course, thank you for your attention today.